Studies Section 6, Integral Calculus, Indefinite Integral. Introduction. This is the process of tracing back a given derivative to its primitive function. In other words, it is a way by which we move from the differentiated function to its original function, that is, reversing the process of differentiation by finding the original or primitive function from the derivative. This is also called integration or anti-differentiation. Thus, the original function f of x is called the integral or antiderivative of f prime of x. For example, if the differentiation of a given primitive function f of x gives the derivative f of x, then we can integrate f of x to get the primitive function f of x back, as long as we have the appropriate information available to definitize the arbitrary constant that will arise in the course of the integration. Invariably, integration involves the tracing of the parentage of the function f of x, whereas differentiation shows the progeny of the function f of x. At this point, we must note this difference that while the differentiation of the primitive function f of x produces a lone offspring, namely a unique derivative f of x, the derived function f of x can be traced to an infinite number of possible parents through integration. Because f of x is an integral of f of x, then also must be f of x plus any constant. The standard notation to denote the integration of f of x with respect to x is integral f of x dx. The left side symbol that looks like an elongated x is called integral sign, while the f of x part is known as the integrand, that is, the function to be integrated. And the dx shows that the operation has to be performed with respect to the variable x. This integral sign, that is in the front of the function f of x dx, gives the instruction to reverse the differentiation process that gave rise to the differential. We can write that integral f of x dx is equal to f of x plus c, equation 6.2. The c is the arbitrary constant of the integration, which indicates the multiple parentage of the integrand. This integral f of x dx is the indefinite integral of f of x because it does not have definite numerical value and generally vary with the value of x, even if c is definitized. The rules of integration are obtained by reversing the corresponding rules of differentiation. The accuracy of this is checked by looking at the derivative of the integral, which must be equal to the integrand. Rule 1. The integral of the constant k is integral k dx is equal to kx plus c. Example, integrate 3 dx is equal to 3x plus c. Rule 2. The integral of 1 written as dx is integral dx or integral 1 dx is equal to x plus c. Rule 3. Power rule, which shows the integral of a power function x raised to power n, where n is not equal to minus 1. Integral x raised to power n dx is equal to 1 over n plus 1, x raised to power n plus 1 plus constant n is not equal to minus 1. Example 1. Integrate x squared dx is equal to 1 over 2 plus 1 x raised to power 2 plus 1 plus c is equal to 1 over 3 x raised to power 3 plus c. Example 2. Integrate x squared dx is equal to 1 over 1 plus 1 x raised to power 1 plus 1 plus c is equal to 1 over 2 x squared plus c. Rule 4. Logarithmic rule. The integral of x raised to power minus 1 or 1 over x is integral x raised to the power minus 1 dx is equal to lim x plus c. X is greater than 0. The restriction x is greater than 0 is added because only positive numbers have logarithms. However, for any negative numbers, it will be integral x raised to the power minus 1 dx is equal to lim absolute value of x plus c. X is greater not equal to 0. Rule 5. Exponential rule. Integral of any exponential function is integral a raised to the power n dx is equal to a raised to the power n over k lim a plus c. Example, integrate 2 raised to the power 3x dx is equal to 2 raised to the power 3x over 3 lim 2 plus c. Rule 6. Integration of a natural exponential function, integral L raised to the power x dx is equal to L raised to the power x over k plus c, since lim L is equal to 1. Example, integrate 9L raised to the power minus 3x dx is equal to 9L raised to the power minus 3x over minus 3 plus c is equal to minus 3L raised to the power minus 3 plus c. Rule 7. Integral of sum or difference. The integration of sum or difference of two or more functions equals the sum or difference of their integrals. Integral f of x is equal to g of x dx is equal to integral function of x dx plus integral g function of x dx. Example 1. Integrate x cubed plus x plus 1 dx is equal to x raised to the power 4 over 4 plus c1 in bracket plus x squared over 3 plus c2 in bracket plus x plus c3 in bracket is equal to x raised to the power 4 over 4 plus x squared over 2 plus x plus c. Integral 3x cubed minus x plus 1 in bracket dx is equal to 3 integral x cubed dx minus integral x dx plus integral dx. Example 2 is equal to 3 into bracket 1 over 4x raised to the power 4 minus 1 over 2x squared plus x plus c is equal to 3 over 4x raised to the power 4 minus 1 over 2x squared plus x plus c. Initial and boundary conditions. The initial condition y is equal to y naught when x is equal to 0, or a boundary condition y equal to y naught when x is equal to x naught uniquely determines the constant of integration. By permitting a unique determination of c, the initial or boundary condition singles out a specific curve from the family of curves. Example, if the boundary condition y is equal to 11 when x is equal to 3, the integral y is equal to integral 2 dx is given as y is equal to integral 2 dx is equal to 2x plus c. Question 6.3. Substituting y is equal to 11 when x is equal to 3. 11 is equal to 2 into bracket 3 plus c. C is equal to 5. Thus, y is equal to 2x plus 5. It should be noted that even though c is specified, integral 2 dx remains an indefinite integral because x is unspecified. Hence, the integral 2x plus 5 can assume an infinite number of possible values. Integration by substitution. The integration of a product or quotient of two differentiable functions of x, such as integral 12x squared into bracket x cubed plus 2 dx, equation 6.4, cannot be done directly using those simple rules above. However, if the integrand can be expressed as a constant multiple of another function u and its derivative du dx, integration by substitution is possible. Thus, integration by substitution is the integral of f of u du ds with respect to the variable x is the integral of f of u with respect to the variable u. Integral f of u du dx dot dx is equal to integral f of x dx. Question 6.5. Integral f of u du is equal to f of u plus c, where the operation integral du has been substituted for the operation integral dx. This rule is just an integral calculus counterpart of the chain rule, which may be proved by chain rule itself. Given a function f of u where u is equal to u function of x, the chain rules is d dx f of u is equal to d du f of u du dx is equal to f prime of u du dx is equal to f of u du dx. Question 6.6. Given that f of u du dx is the derivative of f of u, it follows that the integral of the former will be integral f of u du dx dx is equal to f of u plus c. Example 1. Determine the indefinite integral of this function. Integral 12x squared into bracket x cubed plus 2 dx. Let u is equal to x cubed plus 2, higher power of the independent variable in terms of absolute value. Take the derivative of u, which is du ds, is equal to 3x squared. Solve algebraically for ds. ds is equal to du over 3x squared. Substitute u for x squared plus 2 and the u over 3x squared for ds in the original integrand. Integral 12x squared into bracket s cubed plus 2 ds is equal to integral 12x squared dot u dot du over 3x squared is equal to integral 4u du is equal to 4 integral u du, where 4 is a constant multiple of u, is equal to 4 into bracket 1 over 2u squared is equal to 2u squared plus c is equal to 2 into bracket s cubed plus 2 squared plus c. Example 2. Find integral 6x squared into bracket s cubed plus 2 raised to power 9 ds. U is equal to s cubed plus 2. Then du ds is equal to 3s squared, so that integral 6x squared into bracket s cubed plus 2 raised to power 9 ds. Example 2. Find integral 6x squared into bracket s cubed plus 2 raised to power 9 ds. Let u equal to x cubed plus 2, then du dx is equal to 3s squared, so that integral 6x squared into bracket x cubed plus 2 raised to power 9 ds is equal to integral 6x squared dot u dot du over 3s squared is equal to integral 2u du is equal to 2 integral u du is equal to 2 into bracket 1 over 10 u raised to power 10 is equal to 1 over 5 u raised to power 10 plus constant is equal to 1 over 5 into bracket x cubed plus 2 raised to power 10 plus c. Integration by parts. This is applicable in a situation whereby an integrand, that is, either production quotient or differentiable functions of x, cannot be expressed as a constant multiple of the u dx. It is the process of reversing the product or quotient rule in differentiation. This is when an integral of v with respect to u is equal to uv less the integral of u with respect to v. Integral v du is equal to uv minus integral u dv. Question 6.8. The essence of this rule is to replace the operation integral du by the operation integral dv. The rationale behind this result is relatively simple. First, the product rule of differentials gives us duv is equal to v du plus u dv. Integrating both sides of the equation, we give integral duv in bracket is equal to integral v du plus integral u dv, or uv is equal to integral v du plus integral u dv. Subtracting integral u dv from both sides gives previous function. uv minus integral u dv is equal to integral v du plus integral u dv minus integral u dv. uv minus integral u dv is equal to integral v du. Example, integrate by parts this function below. Integral x plus 1 in bracket raised to power half dx. Let v is equal to x, implying dv is equal to dx, and also let u is equal to x plus 1 raised to power half. Du is 2 over 3 into bracket x plus 1 raised to power 3 over 2. Then we can find the integral to be integral x into by x plus 1 raised to power half dx is equal to integral v du minus uv minus integral v du is equal to 2 over 3 into bracket x plus 1 raised to power 3 over 2 x minus integral 2 over 3 into bracket x plus 1 raised to power 3 over 2 dx is equal to 2 over 3 into bracket x plus 1 raised to power 3 over 2x minus 4 over 15 into bracket x plus 1 raised to power 5 over 2 plus constant. Exercise. Find the following. 1. Integral 16 x raised to power minus 3 dx where x is not equal to 0. 2. Integral 4x L raised to power s squared plus 3 dx. Definite integrals. The theorem of fundamental calculus states that the numerical value of the definite integral of a continuous function f of x over the interval from a to b is given by the indefinite integral f of x plus c evaluated at the upper limit of integration b minus the same indefinite integral f of x plus c evaluated at the lower limit of integration a. Given that c is common to both, the constant of integration is eliminated in subtraction. This is expressed mathematically as integral upper limit b lower limit a f of x dx is equal to capital F of x upper limit b lower limit a is equal to f of b minus f of a, equation 6.10. Integral upper limit b lower limit a is the limit of the integration b a or b a. Indicate that b and a are to be substituted successively for x. Example 1. Evaluate integral 4 1 10x dx is equal to 4 at the upper limit, 1 at the lower limit. 10x dx is equal to 5x squared. 4 1 is equal to 5 into bracket 4 raised to power 2 minus 5 into bracket 1 raised to power 2 is equal to 80 minus 5 is equal to 75. Example 2. Evaluate integral 3x squared dx. Upper limit is 5, lower limit is 1 is equal to x cubed 5 1. 5 raised to power 3 minus 1 raised to power 3 is equal to 125 minus 1 is equal to 134. Example 3. Evaluate integral kl raised to power x dx. Upper limit b, lower limit a is equal to integral ke raised to power x dx is equal to kl raised to power x upper limit b lower limit a is equal to L raised to power b minus L raised to power a. Properties of definite integrals. Property 1. Reversing the limit of the integration changes the sign of the definite integral. Integral f of x dx upper limit b lower limit a is equal to minus integral f of x dx upper limit a lower limit b. Property 2. The value of definite integral is 0 when the two limits of integration are identical. Integral f of x dx upper limit a lower limit b is equal to f of a minus f of a is equal to 0. Property 3. A definite integral can be expressed as a sum of a finite number of definite sub-integrals as follows. Integral f of x dx upper limit c lower limit a is equal to integral f of x dx upper limit b lower limit a plus integral f of x dx upper limit c lower limit b, where a is less than or equal to b, less than or equal to c. Property 4. The sum or difference of two definite integrals with identical limits of integration is equal to the definite integral of the sum or difference of the two functions. Integral f of x dx upper limit b lower limit a plus or minus integral g function of x dx upper limit b lower limit a is equal to integral f of x plus or minus g of x dx upper limit b lower limit a. Property 5. The definite integral of a constant time a function is equal to the constant times the definite integral of the function. Integral k f x dx upper limit b lower limit a is equal to k integral f of x dx upper limit b lower limit a. Exercise. Evaluate the following. 1. Integral 1 over 2x squared upper limit 3 lower limit 1. Number 2. Integral L raised to power 2x plus L raised to power x dx upper limit 3 lower limit 2. Improper integrals. This is a situation whereby the definite integral has an infinite limit of integration. Integral f of x dx upper limit of infinity lower limit of a, and integral f of x dx upper limit b lower limit minus infinity, equation 6.11, are improper integrals because infinity is not a number and cannot be substituted for x in f of x. They can, however, be defined as the limits of other integral, such as integral f of x dx upper limit infinity lower limit a is equal to lim b approaches infinity, integral f of x dx upper limit b lower limit a, and integral f of x dx upper limit b lower limit minus infinity is equal to lim a approaches minus infinity, integral f of x dx upper limit b lower limit a, equation 6.12. If the limit in either case exists, then the improper integral is said to converge. Example 1. Evaluate integral 1 over s squared dx upper limit infinity lower limit 1. First, we know that integral dx over s squared is equal to minus 1 over x. Substitute for the limit is equal to minus 1 over b plus 1. In line with the above, the desired integral is integral dx over s squared upper limit infinity lower limit 1 is equal to lim b approaches infinity, integral dx over s squared upper limit b lower limit 1 is equal to lim b approaches infinity into bracket minus 1 over b plus 1 is equal to 1. This improper integral does converge and it has a value of 1. The expression above is somehow cumbersome. This is the reason why some people prefer to write the improper integrals as integral the x over x squared is equal to minus 1 over x upper limit infinity lower limit 1 is equal to 0 plus 1. Example 2. Integral 3 over x squared dx upper limit infinity lower limit 1 is equal to lim b approaches infinity integral 3 over x squared dx is equal to lim b approaches infinity minus 3 over x is equal to lim b approaches infinity minus 3 over b minus 3 in bracket over 1 is equal to lim b approaches infinity minus 3 over b plus 3 in bracket is equal to 3. L'Hopital's rule. In a situation where the limit of a function such as f of x is equal to g of x over h of x as x approaches a cannot be evaluated. For example, when both numerator and denominator approach 0, giving rise to the indeterminate form 0 over 0, or when both numerator and denominator approach infinity, giving rise to the indeterminate form infinity over infinity. L'Hopital's rule can often be helpful. L'Hopital's rule states lim x approaches a, g function of x over h function of x is equal to lim x approaches a, g prime function of x over h prime function of x. Equation 6.13. Example, lim x minus 4 over 16 minus x squared as x approaches 4. As x approaches 4, then x and 16 minus x squared approaches 0. Therefore, differentiating numerator and denominator separately, we have lim x minus 4 over 16 minus x squared as x approaches 4 is equal to lim 1 over minus 2x as x approaches 4 is equal to minus 1 over 8. This is the end of study section 6. Thanks for listening.